In this video, we'll troubleshoot Vespa startup and configuration. We'll start one config server, one container node, and one content node, all run in the same Docker container. We're at step 4 in the quick start, just started the Docker container. The config server is started as part of Docker container startup. See the Docker file for details. Checking the container. We should see the Vespa container running. Then let's do a config server health check. And it's up. Sometimes the port forwarding from inside the Docker container to the outside can fail. We could have a port conflict. So we can then do the same health check inside the Docker container. Another common startup problem is memory. Make sure the Docker container runs with minimum 4 GB and shut down any other Docker containers when troubleshooting. Finally, check the logs from the config server. What we're looking for here is the application config generation. This means the config server started successfully. If you don't see the logs, make sure you're running the correct image. See the blog post for details. The config server operations guide is also a great resource in this phase. The application package has the schema config and also the nodes and their roles, like the Vespa stateless containers. Deploy will both start a container and content node services and configure these. There are more ways to do this. A deploy is two-phased. It's the prepare and activate phases. The config server will process and validate the deployed config. That means for large application packages, resources can be limiting the config server. If you fail to see the successfully prepared log message, consider running with more memory and use ulimit to validate things like number of open files, threads, and the likes. After application deployment, the config server knows all the nodes in the system. The startup sequence is like this. The config sentinel running on each host in hosts XML will query the config server for what to run and then start the services configured in services XML, like a container or content node. At startup, the service will query the config server through the config proxy for configuration. And we can then query the health API on each. To find those endpoints, we use Vespa model inspect. First listing the services, and here we can check the service container and service search node. And here we are looking for the HTTP ports. Then we can run the health checks. And we see both the container and the search node are up. The container node will emit a log message when it has started. Look for application config generation. The container can run custom code and is hence more prone to startup problems. Here, using the quick start Java, we have made a typo in the config. The custom bundle is built as albums, but the reference in services XML is wrong. So let's check the logs. We clearly see the problem. The most common problem with container startup is a bundle mismatch, like the one we just did. A bundle is a jar file where custom code is packaged, so after building the application you can inspect the target. We see that the name of the jar is not the same as the bundle name in services XML, and the container doesn't start because of that. That's it. Find all commands and links used at the resource center.